Hi, if you don't know me, my name is Mate Aller. I am a postdoctoral researcher at the unit, and I'm going to talk to you about the version control, what is version control, why you would like to do that using Git and GitHub. So in this talk, I'm going to talk about what is version control, the main aspects of it, and basically I'm going to introduce that using Git. And GitHub, there are many different tools that, around, but this one is, I find, the most useful, and a lot of other people's as well. So that's why it's. So this picture may be all too familiar with to you. This particular case when our little nameless hero is working on a final final version of the paper, and the professor is giving comments all the time. And you get this sort of circular, and you like update it, and then you have a new file and another one and another one, and then you end up with a mess at the end. So obviously this is now not code development, but this is very like developing a manuscript collaboratively with someone else. And I just wanted to point out that in this situation, the input is going into the file from one person only, because the professor is giving the comments on paper. So imagine the case when both of them would have access to the same file somewhere else. That would get out of hand quite fast. Obviously, for documents specifically, there are cloud-based tools which are pretty well suited for this. But basically, this illustrates the issue with version control quite well. So in my talk, I'm going to talk about version control in the context of scientific code, be it whatever, or it could be just markdown files, whatever. And yeah, so what is version control? Basically, the practice of tracking and managing changes to software code. Essentially, that gives you a record of every single change to the code throughout the development of that code. So you can think of a project where you just do basic data analysis. You have a script or many scripts. That is already kind of like a project. It doesn't have to be like a standalone whatever function code repository or anything. You can think about this as your project you're working on, basically, to analyze some data. If you have this sort of record of your data, that's already does the major thing of backing up your code, which is very important, because all your intellectual input is written down as part of those scripts. So that's very important not to lose that. So that's obviously one thing you want to do. But also, if you have this record, then you can retrieve an arbitrary previous version of your code at any point, which could be very important to answer reviewers' questions. Or if you find a bug in your code, for example, and then you want to know where that bug was introduced, then you can just track it back. So having all that thing is really useful, and not just useful, it's I would argue it's essential for good coding practices. And because of this, in modern software development, basically there's no modern software development without version control. Everybody does some sort of version control. And as I said, our scientific projects are basically software development, in a sense, not full-fledged, but it's kind of like in a tiny way. And that's why we would like to use these tools as well. And others have pointed this out. So there's a very good paper about the coding practices everybody should adopt for scientific computing, good enough practices in scientific computing. And in that paper, they make several suggestions for all sorts of aspects of your scientific computing projects, but specifically they have recommendations on version control. So back up almost everything created by a human being as soon as it's created. Keep changes small. That's also important because it's easier to keep track of the changes if you sort of like name your changes in smaller increments, then instead of just doing a massive big change, rewriting the entire project and just like say, okay, I just updated the file X, and then everything's changed. You might want to share your changes frequently if you are collaborating on a project with someone. Most of the time, this may not be the case. Quite often, I find myself working on a project just by myself. In that case, obviously, you don't need to share those updates if no one else is using that code. However, at the end of the process, you would still want to share that code as part of as an attachment of your publication. So in that case, it's still good to keep track, and at the end, you can share it very easily. I'm going to demonstrate that as well. Yeah, you can have checklists, saving and sharing changes to the project. Also, like store each project in a folder separately. That's also very important. Not to sort of like keep things separate. And basically, you can achieve this version control either just by yourself manually. It takes a lot of discipline to do that. They have some recommendations for that. Or you can use a more standard version control tool borrowed from software development. So the manual versioning, two of the recommendations, like add a file called changelog, like a text file, and the docs subfolder, and then you basically meticulously log every change to your code. And whenever you change something, you copy the entire project to a different sort of sub directory, so you have your record of those. So you can imagine that's kind of a lot of work, because you write a detailed changelog, which is good to have, by the way, but at the same time, you have to just copy it over and over again. You have to come up with some sort of system of relating that copy of the code to the changelog. You have to make sure to work on the latest version. You have to do all that sort of like copying it over if you want to work on the older version, all that manually. So that's all, you can see, probably very error prone. So why not use a version control system which is off the shelf and everybody's using those things in software development, and you can just learn how to use that. I would argue it's easier to learn to use a version control system than just do the manual versioning. It will definitely be a bit more sort of upfront cost when you learn to adopt them, but at the same time, it will make your life much easier in the long run. So overall, it's going to be much less work if you just adopt that. So what types of version control systems are available? So one is local. Basically, what I just told you about the manual system is a kind of like a local system. You have a version database. You keep track of your versions of your code, and then you just copy them over. The good thing about this is everything you have everything locally. So if you have to come back to check I want to check an older version, it's readily available. You can just go back. You don't need to do anything. And also, it's relatively easy. So you just copy it over all the time. The bad thing about this, that it's going to be local. So if something happens to your PC, then the entire project is lost. So obviously, this doesn't take care of backing it up. And also, it's a bit clunky, as I said. You copy it over everything. So perhaps there are better tools. So another version of version control systems is the centralized, where there's like a main repository somewhere, probably online, and then the history of the entire project is stored up there. And then you as a developer, if there are more developers, they just pull one of those, the latest version, and on your local PC, you would have the latest version of the code, and you're working on that. This is great because this is on an online repository, probably hosted by a trusted company. So hopefully backing up is taken care of. So if you lose your own version, that's not going to lose the entire project. The problem here is that usually you don't have the entire code history on your PCs. So it would take time and an internet connection to go back and track back some changes. So that's also not ideal. So the third one I would like to mention is the distributed version. In this case, basically everybody has the entire project on their PC. There's no one main thing. Everybody is sort of equal in that sense. Obviously, if you set it up in a server, that could be treated as a main, but it doesn't have to be like that. Every single instance of that project is equally as valid as the one of the server. In this case, you are basically having the best of both worlds. You have it locally, so it's very fast. You can change it. You don't need internet access to do changes. And also, it is all saved somewhere else, maybe even more safe than decentralized, because you have the entire project not just in one place, but in all other places. So should anything happen with the server version, then you would still have local versions around at other developers' PCs. So yeah, distributed seems to be like the best option. Obviously, it comes with challenges, how you make differences, etc. But that's basically when the developers of this system come in and they solve it quite elegantly. So I'm going to talk about Git, which has been developed, I don't know, maybe 20 years ago to maintain the Linux kernel project, which you can imagine is a fairly big project. So it has been developed by the Linux kernel team and Linus Torvalds. This is a distributed system, so you have a local copy of the entire project, but also around the world. It's based on snapshots of the system. And what does that mean? So other kinds of version control systems store a file, which is the base file at the version 1, and then basically they store all the changes, the deltas, so to speak, relating to that file, as you can see on this diagram. So in order to retrieve that, you would need to have the base file and all the changes, and you add them all up, and then you have the latest version. Git instead basically takes snapshots of your entire project as it goes along. It doesn't mean that it saves a file every time, even if it doesn't change. If it doesn't change, then it can just store so like a pointer to where it was before. But the idea is that for each version, each snapshot will contain an entire repository, which has a lot of ramification, but it's very efficient way of storing the data as well. Okay. As I said, because it's a distributed system, Git operates locally. So it is a software running on your PC or on your cluster. It's integrated into the terminal, and then all the changes which you make are happening locally, and then you can synchronize those changes with the remote repositories. It has something called integrity, which means that if anything changes in the entire snapshot compared to the previous one, that will flag up as a change. So the way they achieve this is once you have your version, the entire project is pushed through a cryptographic algorithm, the SHA-1, SHA-1, and it will create a hash, which is I don't know how many digits long code, which can only be that code if the input is exactly that. Even if one character changes in the input somewhere in one of the files, then that generated token will be completely different. So that's how there can be no mistakes. So it can't be labeled as not change if there's change. So just to say that's very, very safe, industry standard cryptographic algorithms make sure this is all correct. Git only adds data generally. So whenever you make a change, it will just add, oh, there was a change here, there you go. It doesn't take away anything, even if you delete something in the history, there would be there. In general, I would say you have to work really hard to lose the data when you use Git. Obviously, there are ways to going back. If you made a change which you want to undo, it's not recommended to do it that way. It's better just to say, oh, I made an error there. This is the correction. But you can go back if you made something in error. And it's very difficult to lose data with Git. You can, obviously, but you have to work hard for it. It's a cross-platform application, so it works on all major platforms. It works on the command line, and I would recommend you to first use that way, but they also have standalone graphical user interfaces. For that, I'm not recommending that. I haven't ever used that, never needed. What I would definitely recommend is that all the major modern development, code development environments, such as VS Code, will have Git support. So that in VS Code, for example, I'm going to demonstrate this works really well. So you can use that as a graphical user interface, so to speak. There are certain things which are not so easy to do in the command line. It's very easy if you have it integrated in your development environment. Okay. So basics of Git. So you have your project. This is my example project, some subfolders in that project. In Git, in the Git lingo, you have the working directory, which is your project directory. And you have your repository, which is this .git folder within your project. This is a hidden folder. Normally, that's why it starts with a dot. But all the versioning and everything happens within that folder. So that's what is called a repository in this Git lingo. And the third very important area in this whole Git machinery is the staging area, which doesn't have its own folder. It's really a file within your Git folder, within your repository, and it's a temporary thing. I'm going to explain what that means. So what do you do? So you do changes in your working directory. You work on the project, you add some new features, you had some analysis done. What you do next is, okay, these are, I don't know, I changed 2-3 files, out of which 2 of these changes were related to one thing I wanted to achieve. I implemented a new function and a new feature. I want to put this under version control. So now I'm going to stage these fixes. And those will go to the staging area. So like, okay, these are the 2 things I would like to add to my history. And then once it's there, you can commit them. That's the other sort of lingo, commit to the repository. And that way it becomes part of the whole history. And then the other way around, you can check out any previous change from the repository by, in that case, you basically overwrite your working directory based on what you asked. If you want to go to the previous stage you saved, or whichever you want to go back to. So a bit more sort of cartoon-like picture of this is where you have your working directory, kind of like where you do the changes. This is your staging area, where you sort of like add your changes which you want to commit. And then once your changes are there, you commit those changes into your local repository. And that's the basic Git workflow, really. And you're going to do this 95% of the time. I haven't mentioned anything about a remote repository. You can set up a remote repository, which is typically sitting on GitHub, but you can host that remote repository anywhere in your server, etc. It can be a different folder in your file system, whatever. And then the picture becomes full here. This is when you have your remote repository. You can push the changes which you made to the remote repository, and then you can pull the changes if others have made something, etc. So this is the entire. Do stop me if you have any questions. happy to answer. Okay, so what's the simple Git workflow in terms of commands? So let's say you implemented a new functionality, you changed a few files, and you first say, assuming that you already initialize your repository, which I'm not talking about now, but you have a set Git repository, you added some changes, you say Git status, it's going to give you something like this. On branch main, changes not staged for commit. These are the modified files. And then you can add these files to the staging area using git add. And then you can commit them with the git commit command with the -m flag, which is the message, the commit message. This is, I think, really important. You have to add a one-liner sentence which summarizes your what happened in that particular commit. What did you change? So in this case, it's like add a new functionality to the package, functionality X. You have to be specific. This is not enforced. You can make a commit without a message, but that's usually not recommended because otherwise you just don't know what's happened. And then how to synchronize it with the remote repository. So once the local changes have been committed, you can say first git pull. It's always a good idea to first check if someone else did some changes to the code, and because then if you are saving or synchronizing your changes to a not up-to-date version of the code, then there's going to be some conflicts, which can be obviously very easily resolved, but it's always a good idea to first pull and then you say push. Origin main is just saying that I'm pushing to the origin, which I called origin, the remote repository, the main branch of my work. I haven't talked about branches yet, but there's always one branch when you are working on a project, the main branch. It used to be called the master branch. If you're looking up GitHub stuff, Git and GitHub stuff over the, just looking how it works, etc., Googling it, you might come across the master branch. It's the same as the main. It's an older version. They replaced it with the main. Okay, so once again, this is the full picture. So you do some changes in your working directory, you stage them, you commit them, and before you synchronize them to the remote, you first make sure that you're working on the latest. You do a pull first, and then once it's all good, then you can push. And that's it. Any questions so far?
Two short things. How do you know?
The microphone.
Sorry. Thanks, Monty. How do you know when you are about to pull that it's not going to overwrite the changes that you just made? So when you pull, is that overwriting the code that you have? Okay. So it's just a sort of comparison operation?
Yes. It doesn't affect your working directory, the pull, it's just your repository. If you say pull, then it will just collect that, oh, your branch is now whatever X commits behind the remote, and then it will do a detailed analysis. If you're lucky, then you haven't changed the same thing as someone else, and then it can just fast forward your repository to the stage of the remote. Or if you happen to make a change to a file which has also been changed there, then you have to do a merge conflict. Like you have to resolve the conflict using a merge command. Once again, it will pop up a window you have to go through by hand, and that's something you need to understand what the other did, etc. But yeah, that's how it works.
So pull doesn't actually bring any code to you; it just compares with the branch.
It's a good question. If I think it will. So if there are any, so if you haven't done any changes, you just want to know if there's any update, you just git pull, then it will update your working directory. That's my understanding. But if anything is conflicting or anything, then it will tell you. So it's not going to ruin your project. No.
And secondly, is there any circumstance in which you would want to stage but not commit?
always staging just before committing, so I'm not doing that. But you can, so if you're very disciplined and you know that I'm going to work on this one thing right now, and then you can just stage whenever you do a change. You can, if you change that same file again, then you have to stage it again. So it can be an iterative process. So some people do that way.
Thank you. I was just interested. I've never staged and then not committed. So
Yeah, me neither. I think there was something online.
GitHub for remote repository.
Yes, absolutely.
There's also this university thing that
GitLab.
GitLab, yeah, that also we have.
Yes.
University.
Yes, I haven't used GitLab much.
I know that some people, some groups review, like we had this presentation,
Yes.
like giving groups.
Yeah, GitLab works once again based on the machine. GitLab is like an open source set of functionalities which anybody can sort of instantiate, the University of Cambridge or whoever. GitHub is obviously used to be a standalone thing. Now it's part of Microsoft, but it's still free. I'm going to talk about GitHub later, but I'm not going to talk much about GitLab. But the idea is that, yes, I would recommend GitHub to host your remote repositories, but individual circumstances may suit one or the other.
Just a disadvantage of using GitLab would be if you leave university. I think that's the key time how to get to it. Well, when we had this previous talk, it's this option.
Yeah.
They may so that they would still have access, or maybe more effortful if you
Yeah.
leave the university. Well, with GitHub, it always.
Yeah, lots of code is shared on GitHub, so I think it's a good idea to do it there. Okay, so
can I just ask one quick question about the pool?
no? I'm having trouble understanding you.
Sorry.
Very, very.
Okay, don't worry if it's bad. That's fine.
Can you just ask again?
I wanted just to ask with the pool.
Yes.
If you have made a change to part 2 and someone else has made a change to part 1 and you do a pull, what happens if you don't like their change to part 1 and you weren't aware of it?
Well, that's the point where I'm not sure have you heard what was, so basically the question was whether if you make a change in part A and then someone else may change to part B and then you make a poll and then you're not happy with those changes, what can you do? Yeah. So in that case, you basically, so there are ways to deal with that in GitHub. So in GitHub, usually there's someone responsible for the development of the code. And in that case, you always push your changes into a new branch, which I'm going to introduce right now. And then you can request the maintainers of the code to pull that into their project, which is called the pull request accordingly. And then before they pull it in, they can review it. They can make sure that it's aligns to their standards and everything. And then whenever they are happy with it, then they can pull it in. So that's the proper way of doing that.
Fantastic. Thanks. Good answer. Thanks very much.
Sure. Okay, so branching. So obviously, when you have your own project, I usually have a very linear development pattern. So I don't need usually branches. But there are certain situations when I'm, training neural network models and I want my code to be functional whilst I'm developing a new feature. In that case, I don't want to ruin my main line by doing some new thing which could break all their functionalities. In that case, I would branch off of my main project to implement my new feature. And then once I'm testing it, everything is tested and it's fine, then I can integrate it back to my original project. The same goes for bug fixes. So that's branching. Basically, it's a very straightforward concept. It can get very messy if it's more complicated, but Git is very good at handling these things. So basically, the command is just git branch that lists all the branches. There's always the main branch, which I mentioned already. That's where you're working on. You can create a new branch by saying git branch and then give it a name. and then you can check out that branch from your repository using git checkout and your branch name. And then once everything is all good, then you go to the main branch. Let's say you want to integrate your branch in the main, and then you say git merge and the name of the branch which you would like to integrate into the main, and that's it. Obviously, there's a lot of things going on here. You don't need to remember this. One thing my recommendation is just keep a Git cheat sheet handy. That's going to be one of my last things to mention. If you use this enough, then you're going to know these by heart, but it's easy enough to keep a cheat sheet next to you. Okay. So now I'm going to move on to GitHub. So the GitHub, again, is a separate thing from Git. It builds on Git functionality and infrastructure, but it adds new functions. So it's a web-based platform to store, share, and collaborate on code. It adds tools for collaboratively developing and maintaining code, such as error reporting functions, making requests to update to the code, discussions around those requests. It also implements advanced code development tools like continuous integration and code review, etc., etc. We don't need to talk about that. There's a free plan available, but obviously there's enterprise version, etc. But one thing I would like to highlight is that there's GitHub Education, which everybody in the world who has a GitHub, an educational email address can apply to, and you can be as a student or a teacher, and it gives you functions for free, which are otherwise not free. Okay. So that being done, I'm going to move on to some demos. I'm going to sit down if that's all right. I'm going to first demonstrate a very simple Git workflow. So if this is my coding environment, you can see this is probably it's too small. Better. This is where I set up an example project. You know, some empty directories right now. I have a data folder, a docs folder, notebooks, reports, scripts, and source files. I'm going to make changes to the src source file directory. So as you can see, this is not a Git repository at this point because there's no .git folder. So let's first make some changes. So I'm just going to create a new file. And I'm going to save this to here, and I'm just going to name this. Okay, I've got this little file. Okay, now how do I initialize this? So for that, we need the terminal. I'm just going to do this through the terminal first. So this is, you can think of this as any external terminal window. It can be PuTTY or whatever. I happen to start it from my environment because it allows me to do that, but you know, it can be an external terminal. So just to make sure that I'm right where I want to be, this is the same folder as here. So if I say git status, then obviously it will throw me an error because this is not a Git repository. So I first need to initialize it. So I'm going to do git init. And now you can see that there's a Git folder here. So our repository is initialized. I can say git status again. On branch master, as you can see, this is an older version of Git, and it still has the master. This is on the CBU cluster, and the old version of the Git is still a very old version, so that's why it has the master branch. And then I have a list of untracked files within src. So what I can do, I can add them. Git add. You can add them by name one by one, or you can just say dot, and it will add everything. You can see now we have new file, source hello world. You can check. Log. Yeah, there's nothing yet, so there's no log yet. So I'm going to say git commit initial commit. You can see there's one file change, etc. If I say git log again, then you can see this is the commit. This is the identifier of the commit. This is the SHA-1 token, which is automatically generated. So basically, Git identifies these initial commit by that SHA-1 hash, author, date, and then what was the commit message. You can do something more fancy if you set it up in your Git settings. You can say git hist, which is going to put like a more detailed version of that, gives a shorter version of that hash, the commit message, the author, and this is the head master. Okay. Head means this is the latest version in the GitHub lingo. Okay, so this is how you do basic initialization. But we don't have the remote repository set up yet, right? So for that, we want to set it up. So let's just do this in GitHub straight away. So this is my GitHub page. I can create a new repository. I say my project. This is going to be a public repository for the sake. You can have it private. I think you can have private repositories if you're using the free plan. I think that's still the case. But if you have the education plan, you're going to have the option, obviously, to have private repositories. This is something to consider if you're happy for the world to see your code as it develops, or you would like to keep that private until you're very happy with it and make them public once the paper is published. This is something I don't have. I did the private thing first and then publishing it. Up to you. I'm not going to initialize anything. I'm just going to create the repository. So this will give me a link. I can copy that. And here I can say git remote. Oh, I need to see. So first I'm checking there's no remote setup. Obviously it's not, because I haven't set up one. Git remote add. I think I can do this. Nope. Sorry?
We start the remote.
Yes, before that, but then it's fine. Okay. Thanks. This is where it comes in handy when you set up something to have the Git cheat sheet next to you. Most of the times I'm not setting up this way, so bear with me. This gives you a realistic insight of how code development works most of the time. Sorry? Oh, okay. There you go. So my origin is now, yeah, I forgot to add the name. So yeah, this is my, so if I say git push, I add the flag u, which set it up as upstream. I'm going to explain that, and say, oh yes, Austin. Okay. So with this u flag, I set it up such that if I call git status ever again, it will compare it to the master in the cloud. So if I make a change, then it was like, oh, this is now one commit ahead of your remote, etc. So that's basically it. And you can go back to your project here, just make a refresh. There you go. I have it under version control with my little hello world thing. Okay, so that's the basics of it. And once again, this sort of like git status, add, commit, maybe maybe diff, that will be 95% of what you are doing in Git. Okay, so just to demonstrate this, the functionalities with a more sort of mature repository, this is what Dots and I are developing here at the CBU, converting MRI and MEG data to this sort of universal neuroimaging data format, the BIDS format. So here, this is like a more elaborate project. And once again, if you go to the, this is the same command line which you see before. If I say git hist, which gives me the list of history, you can see that there's been quite a lot of commits already. So it's a very rich environment to go back to. You can see how we did that. We have issues tracked on GitHub, and we address those issues using these tools. I wanted to tell you that, okay, this is definitely fully functional if you do the Git things through the command line, but as I said, it's integrated into the source control plane here. You can see the source control graph here. You can hit Git graph. As you can see where there was a branching or more branching, and the development goes back to last December, I think. And you can make commits here directly once you have something changed. And if you change something, you can add them through this interface. It's very handy. I would recommend to use that if you're using VS Code. And I'm pretty sure that other development environments have that very similarly implemented. Okay, how does this look like on GitHub? So this is the bits conversion. This is the remote now. You can see there's a README, there's a Meg and an MRI folder. And I mentioned that there are collaborative tools in GitHub. For example, you can report issues, which are maintained here. I can also go back to all previous issues which have been solved. This one was pretty good. There were 7 comments. You can see somebody suggested it. I put it up there. There were some changes. Whenever you make a commit in Git, which references that issue number 10, in this case, that was issue number 10, then it will pull it in here automatically. So everything is in one place. There are suggestions from other developers. And at the end, it was all fixed and resolved, and you can close it. So that's one thing you can do. Okay. Right. What else can we see here? You can see that you can make releases here on GitHub, because obviously what you see on GitHub right now is a snapshot of the current latest version. But this is not a named version of the file. You can make a named version, so-called release, like version 0.0.0.0.0.1. And some of the functionalities require that. So for example, if you want to add the digital object identifier DOI to your code, then it will require that to be a named release. So it can be you can precisely relate that DOI to a specific version. That makes sense. Okay, any questions regarding that so far? Yes?
I wonder if you have any comments on working with large files that are generated on if they're too large to
Yeah. Short answer, large files are not suited for GitHub. Is it like large text file or data, you mean?
Data.
No, data is not for GitHub. I will talk more about that in a second. So GitHub is optimized for text files, because when it checks the files, the differences between them, it only works with text files, so no binary files, no images or anything. And it makes it very inefficient. It is possible to track, images, etc. The problem is that every single time you make a new commit, that image or that data file will flag as a different one, because it cannot substantially check if this is the same thing or not the same thing, because it's not text file. So there are specific platforms for that. I'm going to mention that. Okay. Right. So another thing I wanted to show you is how it looks like when you publish your code with your paper. This is one example I did. So this is a paper we published in 2022, and this is how it looks, the source code for it in README file. So I put everything up on GitHub and made a nice intro to it, how to use, etc. I made a release. As you can see, this is now the 0.1.1. There was 0.1.0 before. I made some changes afterwards, and everything is nicely documented here. And I added a digital object identifier to it, because it is encouraged nowadays when you publish code with your paper. So the way to do that is through a service called Zenodo. I have it here. So there's a nice tutorial on the GitHub document pages, how to do that. But basically, you need a Zenodo account, so you can set that up. You have to log in to Zenodo using your GitHub credentials, and then you have to add access rights to Zenodo to your entire GitHub set of repositories. And once you've given that, you can have this drop-down menu, the GitHub, and it will list all your repositories and the one which you enabled for this DOI badge. As you can see, I have two at the moment for two papers. You just basically, you can just say, click on, and then you need to make a release of that particular repository. And then once that release is done, Zenodo will know about it, because it is now connected through your GitHub. So basically, it will add automatically this object identifier. And basically, if you just click on it, you're gonna get a link, so you can embed this link to your README file, so that you will have this nice badge on top. And more importantly, if you are going into this, you can see that there were already two releases made. Each has a different digital object identifier, so you can specifically relate to a certain version. You can go in there and you can see the entire set of files, the entire repository saved as a snapshot. And this is associated with that particular digital object identifier. So it's easy as that. So basically, just connect to Zenodo, click a few buttons, and then you have a digital object identifier. Okay, I think that's all for the demos, and I have a few more slides. Is there any questions regarding the demo? Yes?
Thank you very much. That was super clear. I noticed in your beautiful README file, you have a lot of dependencies listed.
Mhm.
I was uploading something for publishing some code recently, and I ended up, well, when I was developing the code, we pulled down some other people's Git repositories to get access to their code. And then I wanted to upload the whole self-containerized thing. So I ended up just writing in the README file with deep thanks to whoever it was of linking the original repositories. What is the best practice? Because obviously you don't want to say, oh, here's a link to the code that original developers updated. It no longer is compatible with the project.
Yeah. Yeah. So one way of doing that, if you use Python, is that you can set up your coding environment and you can create this environment file, which will list all the dependencies specifically and their specific versions. So that works if your code from someone else is on a repository, which you can install using pip or conda. If that code is not, that's a bit more tricky. In that case, you need to have some sort of way of relating to that particular version. If that was on GitHub, then you can definitely say, okay, I use this particular commit. You can do that. It's a bit more tricky. If you go back to my code, you can see that this is partly MATLAB, partly Python. So for MATLAB, I have just listed these dependencies, and then the Python dependencies are in the environment.yml file. So yeah, best thing if all those are released enough, and you can put them in the environment file. Otherwise, you need to just put in there as much as you can to locate it. And there's also an option of containerize it using Docker. So in that case, your entire environment and everything can be like a working image, and others can load that image and then use your code. I haven't done that, but it's a bit more involved.
There's a question online. Is there standard structure for GitHub repository like this? Can you quickly talk about the other folders you had in your project in your local PC?
Yeah, there's no standard. I looked for, so basically mine is based on a standard data science folder structure. Everything data is in data. So obviously but everything related to bids has its own nomenclature. So in my data folder, I would usually have a raw data folder and source data folder and derivatives folder, which is all bids. So I'm not going to talk more about that. The doc folder, it's also included in this good enough practices in scientific computing paper. They also have some recommendation on folder structure, but the doc folder receives everything, which is like a document or some information, etc. The notebooks, I'm using Python most of the time, so I'm using Jupyter notebooks, and that's a bit of a kind of like tricky thing because it combines code with data and output files, so it's not easy to source control. I'm going to talk about that very briefly. So that's why I have a separate folder for the notebooks. I have a separate folder for the scripts, which are usually bash scripts, so all like shell or terminal command scripts, which I keep separate from the source code, which is in the src folder, which is my Python, because Python has a very sort of rigid way of looking at sort of repositories, sorry, not repositories, packages, etc. I keep that separate there. And the reports folder is when I export reports from my notebooks in HTML format with a time tag, that all goes there. So I have a time tag of my results in that folder in HTML format. So in my folder, I'm not putting any version control, only on the src, the scripts, and the notebooks. The rest is not under version control.
You can give a mention of
I will get there in a second. Any other questions? Okay. So I'm going to go back to my presentation and finish this. So what not to put on the version control? Obviously, I already mentioned data, images, and other binary files. So Git is optimized for plain text. If you want to put data, anything else on version control, then you could look at DataLad, which is an open source, free to use platform. It works very similarly to Git, only it works with data. So that's one thing to keep an eye on. If you're using Jupyter notebooks, which combine data with output, and sorry, code with data and output, you would first want to remove all the outputs from your file before making a commit. You can obviously commit, but it's going to be bigger because there's images in those or whatever you create. So as a standard step, I remove all the outputs from my Jupyter notebooks and I make a commit. And then before that, I remove everything. I export that notebook into either PDF or HTML, and I put that into reports. So I have that in one place, which is very nice to look at. You have your code and your output there, so you can easily show that to anyone else, because HTML is, you just need a web browser. You don't need a specific coding environment to open a file. So if you're talking to your supervisor about your latest results, it's easiest to do it that way. Otherwise, yeah, so that's what I do with Jupyter notebooks. Obviously, you shouldn't put any sensitive data under version control, because that once you put it there, it's going to be part of your history. So there are ways to remove this. It's not enough, oh, I put someone's name in there, I'm just going to remove it now. The problem is that it's going to be all the way back there. So there are tools for do that. So basically, you have to go back to every single commit and then remove that information from that file, from that whole history. And also, funny thing, lots of people use cloud computing services, and there you have access tokens and everything. People usually put that in the top of the script and then push them on GitHub, and then you can just see the access tokens. Something to avoid. There's a hard limit on GitHub for file size. Individual files cannot be larger than 100 megabytes. But if you're talking about scripts, text file, that's really hard to have like 100 megabyte text file. That requires a lot of code. So that's usually not a problem. There's a not strictly enforced limit on the size of the repository, which is, they encouraged less than 1 gigabytes and definitely less than 5, but I never heard that they're going to enforce it like strictly. But the 100 megabyte per file limit is enforced. And the gitignore file, you can put a .gitignore file into your working directory, and then you can just list all the kind of things you don't want under version control. For example, I would put data doc reports folders there. You can use sort of wildcard characters. So anything starting with scratch underscore, which I use sometimes scratch scripts and everything, will not be put under version control. And all the, for example, image files, anything like an image or a vector, whatever you basically want. So it's just a plain text file with these sorted as a list. Okay. How can Git make your code better? Well, I think the secret ingredient is the commit message, because then you have to distill your change into one intelligible sentence, which is informative. That makes you, for example, clean up the mess before you start it. It happens all the time with me as well. So I did something, I haven't committed it. Oh, before I can commit now, okay, let's just clean this up. And now we can start and make sure that I'm just including something which is related to that particular change. It makes you bundle changes that implement a single fix or feature to the code in a single commit. So it gives you more structure that way. Just a bit more thoughtful about, okay, what I'm doing. It will prompt you to work on one feature or fix at a time this way. Or if you're working on parallel things, then you can compartmentalize them into separate branches. That's also going to improve your code reliability. You're not going to make that many errors. Also, if you notice that you have to change the same thing in 7 files before you can commit, then that may prompt you to put that one thing functionality in a separate function, which is eliminating code repetition. That's also very useful. And then some of my best practices that keep a Git cheat sheet handy, or Stack Overflow. Nowadays, ChatGPT, it's not a shame of looking at this up. There's like hundreds of GitHub messages. Once again, 95% of the time, you're going to use Git status, Git add, Git commit. But if you want to do something more elaborate, then you have to look it up. You can be a bit more elaborate on the commit messages. You may have seen it. So I had these little prefixes like feed, colon, fix, colon, chore. So these are sort of like, the ideas comes once again from professional software development. This sort of marks the intent of that commit. So you can immediately see if there's like a feature fix or a feature change or whatever, just something, a refactoring of the code, doesn't add anything, just change it a bit, or just documentation, etc. If you're working on a shared project, it's good to see. Also specific to research, if you go to a conference, present a poster, a talk, etc., it's a good idea to just to make a commit in your repositories, like, okay, this is the stage when I went to this conference, and then you know immediately when you want to see something, and you can just go back to that, because otherwise it's hard to know when it was definitely, etc. It's, I think, a good thing to remember. And if you're really a pro, then you can keep a detailed log file, a document, which basically you can detail your changes. Like, okay, I'm doing this because we had this discussion with that person, etc., etc. You may choose to put this under version control within part of your folder. That's the strictest possible thing, because then all your everything is going to be all time tagged and everything, but it's a bit more advanced, I would say. I don't put that on the version control, but I have that file indeed. Okay, some of the resources just to list here, so you can go back to them. And thank you very much for your attention. I hope that my little introduction was a bit more useful than this one on the screen. Any further questions?
Thank you a lot.
Somebody raised hands.
Thank you a lot. Somebody else. Oh, there's fantastic talk and demo. Thanks, Martin. In terms of data sharing, could you possibly briefly discuss pros and cons of GitHub compared to Jupyter Notebooks?
The two are not mutually exclusive, I would say. You can put, as I said, Jupyter Notebooks under version control. You can put Jupyter Notebooks without put under version control. That's possible. Just keep in mind that in that case, everything will be marked as a new thing, because there's always, the output is changing. So I would say for sharing your data as a part of the Jupyter Notebook, I would say if you are sharing this with a paper, then you could put the final version, which is tagged to that particular paper, into the repository, and then you're not changing that later on. So that's all good. So basically everything is there, but it's not going to be with the output. It's all version controlled throughout the history, but just the final one, which you publish with the paper, they will have the input, the output of the the graphs and everything, and then that's shared.
If you go to the last previous slide with resources, and please ask your question. Person who has hand up. Can you ask your question?
Oh, hi, could you hear me?
Yes.
Oh, all right. Thank you for the introduction. It's quite interesting. So my question is that, as for those public repository, so maybe when I checking it, I found maybe there is maybe problems or bugs. I want to maybe share. Maybe I found, and I'm not the owner for this public repository. So how can I maybe make the change, or maybe let the owner know there is a problem, so I can maybe upload the latest version for it?
Yes. Very good question. Thank you. I can show you that quickly. So on GitHub, just a second. There's a way of, so this is my set of projects, and you can see that I have several repositories, one of which is MNE Python, which is definitely not my. This is a really big project, but I contributed to it. I was encouraged to fix a bug which I found myself, So what you can do, this is the original repository. I'm just clicking on it. So this is the one maintained by the people. What you can do, you can fork it. This is one again another GitHub lingo. You can click this and fork it, which will put that entire repository in your account as well, a copy of that, which is now sort of connected to the original one. As you can see, it's been a while since I updated this. So it's 586 commits behind that because it's about a year ago. So I can just hit sync and then update the whole thing. It's going to take some time. So what you can do once it's all up to date, then you can do your fix in your own repository. You can push that into your repository, and once that's done, you can make something called the pull request. So you say that I'm offering these changes to the developers of the project as part of a pull request, and they can review that change and then decide whether to put it in there or not. You can have a discussion around that. They can suggest, okay, this is good, but you should put this and this there. You do that. You can do some back and forth. And then once they are happy, it passes all the tests and everything, they can put it in the release. Yes?
With software like that, like any punishment, the first thing should be to raise an issue. So there's always the possibility to let the developers know, to raise an issue and say, I've come across a bug or I have a suggestion. And then they can tell you whether you should fix it, whether you can fix it, because you might not have time to fix it.
Not sure the online audience heard this, but basically the idea is that if you find something and it's not properly maintained code, then you should first always raise an issue. As you can see, there are several of them. And then this is indeed how I did it. And then once we figured out what's the issue itself, they said like, oh, would you mind fixing it yourself? And then you can do it, and then they would put it in there if they are satisfied. So yeah.
The developers themselves decide.
Yeah.
All right, thank you so much.
Any other question? Okay.
Thank you.
Right. Thank you very much.